皆様お待たせいたしました。それではランチセッションを開始させていただきます。コミュニティマネージャーオープンスタックファンデーショントム・フィファイルド様より Learn OpenStack オーバーランチと題してご講演をいただきます。なお当セッションでは同時通訳がございます。チャンネル1番で日本語をお聞きいただけます。同通レシーバーがお手元にない方はスタッフがお配りいたしますので挙手をお願いいたします。よろしいでしょうか。それではトム・フィファイルド様よろしくお願いいたします。
Hello everyone. As you've heard, my name is Tom Fifield. I'm a community manager with the OpenStack Foundation. But before it was my job to look after people, I was first a software engineer and then a system administrator. And so I've actually built some quite sizable OpenStack clouds. So I thought while you're eating your lunch, we can go through some of the more technical aspects of OpenStack. So Mark in his keynote probably didn't go through many of the components, but you can probably understand that with a cloud computing solution, we deal with compute, network, and storage primarily. And OpenStack, of course, has projects which cover all of these three areas. On the compute project, kind of what you do is you get some servers, you put an operating system on it, you choose a hypervisor of your choice, and then OpenStack controls all of those servers and enables you to have a full private or public cloud. Now, one of the interesting things about OpenStack is it's very, very pluggable. You're able to use more or less any hypervisor. You can plug in KVM, VMware, XenServer, LXC, Docker. It's even possible to use bare metal. And OpenStack can control all of these resources and make it easy to manage your infrastructure. On the storage side of things, there are a couple of different types of storage. The first of which is block storage, which is kind of like when you go to the PC store, maybe you go to Akihabara, you buy a USB hard disk, and you choose the size for your USB hard disk, and then you bring it home, and you can plug it into your laptop, unplug it, plug it into your PC, and it's you who chooses the size and what machine it's plugged into. OpenStack block storage is like that, but for virtual machines. You select the size and plug it into whichever virtual machine you wish. And like the compute section, that's also very pluggable. You're able to use existing storage if you're using EMC, NetApp, Hitachi, Fujitsu storage. You can put OpenStack in front of that and turn it into cloud-enabled block storage. Or, of course, you can install directly on an storage service. And one of the other kinds of storage is object storage. If you're familiar with Amazon S3, you'll be familiar with the model of object storage. Essentially, it's really, really scalable storage built on the idea that storage hardware fails, and the system should deal with those failures. Storage is accessible through a RESTful API. Basically, you put objects and get objects. It's really simple, but it allows you to have very, very large-scale storage, and you don't have to really care about how the bits are being stored. And one of the exciting bits in OpenStack is this software-defined networking component. So right now, to configure VLANs on your switches, to change the networking topology for a particular application, you probably have to log in manually to a switch to change the VLAN configuration. With OpenStack, it's able to talk to your networking hardware. If it's from Cisco or Juniper or Brocade or any of these kind of companies, OpenStack networking can configure that hardware for you, enabling you to create very complex topologies in your network that are custom for your applications. And so of course, there are a few different services that tie things together. There's an identity service, which you can plug into your LDAP or Active Directory. There's a virtual machine image catalog, which manages what virtual machine images you store and where they are stored. And all of this is accessible through an API, dashboard, or command line interface. On the technical side of things, OpenStack is about 1.7 million lines of Python code available under the Apache 2 license. And it's designed on a share nothing, distribute everything architecture. But what does that actually mean? So in real terms, what are users doing every day? When they're accessing compute resources, say you want to choose a particular size of server, a certain number of CPUs, RAM, storage, that's easy. That's a single form in the dashboard, a single command line interface or an API call. You can then suspend that server or snapshot the server and back it up. With networking, maybe you have a limited number of IPv4 addresses and you want to share those between servers. With OpenStack, it's easy to specify a particular IP address and assign it to a particular virtual machine, and you can reassign it very easily with the same command. Or maybe you have a group of applications which use similar firewalling, such as a bunch of web servers which use port 80 and 443. You can make a security group which enables you to allocate that firewall easily across many virtual machines. Or maybe you want to create a private network so that your database server is able to contact your application but doesn't go anywhere near the internet. That's easy with OpenStack. And on the block storage side of things, as we mentioned before with our USB hard disk example, basically what you do is say, create a 100 gigabit volume and then attach it to this certain virtual machine. Or you can take a snapshot of that volume and back it up. And with object storage, if you have your family photos that you want to share, it's really easy, just single command to upload those. And again, to make the files accessible, it's really easy and straightforward to do that. People are also doing very complex things with object storage, which you can run in a standalone manner and plug that into a content delivery network, for example. Of course, all of this functionality that I've mentioned and much more is available through a dashboard, which has been translated into the Japanese by the Japanese OpenStack users group. And if you're more of an application developer, you'll love the REST API. So command line maps straight into the REST API. This is a command used to boot a virtual machine image, for example, and the HTTP post request. And of course, there are bindings for a number of different languages. This is a Python example, but you've got SDKs for Go, Ruby, C#, Java, all of the languages that you care about. You can actually talk to the OpenStack API with them. OpenStack project is very, very active. So we're very lucky to have more than 14,000 individual members of the OpenStack Foundation. And individual membership is free, and anyone in this room can join and start participating in our community. Very, very cool as well is we have more than 1,400 software engineers that have contributed code to OpenStack. In a 12-month period, we get about 800 to 1,000 contributing code. So a very, very large amount of developers who are working for you to produce excellent cloud software. And they come from hundreds of different organizations. We have a very global community. OpenStack is in use or being developed in 132 different countries. And one of our biggest and best user groups is right here in Japan. So you're very lucky that you have access to a large community of people. And you can join their mailing list and communicate in Japanese and ask the experts there some questions. And what this really open community has resulted in is very rapid innovation. So we've produced, as Mark said earlier, almost 2 million lines of code. And for the software engineers in the audience, you'll be interested to know that about 1 million lines of code has also been deleted. So the code is actually under constant refresh and being renewed and tested and improved. Very high quality. And just to give a quick word to some of our sponsors, you can see that there are a number of large organizations who are very involved in OpenStack. There's some fantastic Japanese names here as well. We have NEC, Fujitsu, and Hitachi recently joined as a gold sponsor of the foundation. And there are hundreds more organizations that we can't fit on these slides. So getting into more of the technology, what does the architecture of OpenStack look like? So essentially, it's a collection of RESTful web services. All of these connect to each other using the API, like a service-oriented architecture. Let's go through each in turn. So the compute service, of course, manages pools of VMs on the compute nodes. The image service provides an image catalog and a delivery service, so you don't have to worry where images are stored. The identity service handles all of your login, authorization, access. And the network service manages connectivity for all of those virtual machines. The block storage service, as we saw before, enables you to have persistent storage volumes, which users define the size plugged into those virtual machines. And the object storage service makes it really easy to put and get binary data, so you don't have to worry about how it's stored, and it will just scale to deal with your application. And that can be run as a standalone product. In this case, we're also going to use an example where we're configuring the image service to store virtual machines in the object storage. And of course, there's a web-based dashboard which provides a nice user interface to all of this. So if we look at an example quickly, a very common example. Let's say we have a web developer named Alice who needs a server, let's say it's an Ubuntu server, to deploy an application for testing. So she can simply start a server by logging into the OpenStack dashboard, requesting a certain virtual machine image, in this case Ubuntu 12.04, and then attaching it to a particular network, MyNet. So how that works on the back end is first, when she logs into the dashboard will contact the identity service to get a token for that user, which can be used to represent the user's wishes inside the system. The dashboard will then act as an API client of the compute service, passing the token and sending the request for a new virtual machine to the compute service. The compute service then contacts the image service and requests download of the particular Ubuntu 12.04 virtual machine image. And in our example here, the virtual machine image catalog has been configured to use the object storage. So it contacts the object storage service to download the virtual machine image and return it to the compute service. The compute service at the same time will then contact the networking service and request information about the routing and IP address configuration of that particular virtual machine. And then once it's got all the information, the virtual machine will start by talking to the hypervisor, providing the virtual disk, the network information, and the virtual machine image. And then our user's happy, can see the machine and log in, for example, using SSH. So overall, what Alice might do down the track is use more services of OpenStack. She might use the compute service for web servers, set up some load balancers and a private network for her database using the networking. She might store her code and its configuration on the block storage service and put larger application assets, including user-uploaded files for the application on the object storage. And then there is a database as a service functionality in OpenStack in beta, and maybe she'll use that for her database service. But of course, we're looking for a bit more technical information during this presentation. So let's look at the compute service. Services in OpenStack are implemented using daemons under Linux, and you can see them marked with a star here. And if we look at all of the services here, the Nova API service in the top of the diagram is used for receiving the user requests. And the Nova Compute service, you can see next to that, is used to coordinate what goes on in the hypervisor. The Nova Console Auth, Nova Console, Nova VNC Proxy, and Spice Proxy services are used to provide a way for the user to access the console of the virtual machine and the VNC information without having access to the hypervisor for security reasons. The Nova Conductor service also is for security and scalability reasons. It mediates access to the database. And then the Nova Scheduler is responsible for determining where in all of your physical machines that particular virtual machine should live. So if you're familiar with Python, you may have heard of Eventlet. All of the daemons in OpenStack use Eventlet to manage multiple requests, so they're non-blocking and can be very scalable. We use SQL Alchemy as a database abstraction layer. MySQL seems to be very popular for production databases. SQLite is, of course, for testing, but some people prefer to use Postgres. And one of the things we'll look at during this presentation is the message queue. So if you're running Ubuntu, you'll have RabbitMQ. If you're running a Red Hat or CentOS-based system, you'll use Cupid. And you can also use ZeroMQ for your internal messaging service. So this diagram is the architecture of a previous version of OpenStack. You can see it looks very big and very complex. We don't have time to go through everything today. But if we can go back to our earlier example and just focus on the compute service, many of the other services work in the same way. So, as before, the service request comes into the Nova API daemon. And what the Nova API daemon does is put a message on the queue saying Nova schedulers, because of course you can have more than one Nova scheduler. This is a new virtual machine request with these properties. The Nova scheduler will then pick up that message off the queue and determine which Nova Compute service has the best available resources to run that virtual machine. When it's selected a Nova Compute resource, it will put a message on the queue, and the particular Nova Compute service can pick up that message, and it knows that it needs to start a virtual machine with an Ubuntu 12.04 image using the network MyNet. The first thing it does, as we learned before, is contacts the Glance API. Glance is the code name for the image service and requests to download the virtual machine image. It will also contact the networking service. Now, apologies, this diagram is out of date. Quantum has been replaced with Neutron. So apologies for the poor diagram, but the same services exist. And it will ask for the IP address and routing information. Once it's got that information, the Nova Compute service will then talk to the hypervisor and feed it that networking information and the virtual disk, and you can start the virtual machine. And that's what's happening on the low level. Lots of messages passed on that message queue. So anyway, if we go back up a little bit from the very technical to answer the question, what exactly is OpenStack? And we have this mission to produce the ubiquitous open source cloud computing platform that will meet the needs of public and private clouds regardless of size, being simple to implement and massively scalable. And at this stage, we're doing fairly well in the mission. If we look at ubiquitous, we have actually had downloads even from the research station in Antarctica, meaning we have users on all 7 continents. If we talk about scalability, some of the largest public clouds in the world are running OpenStack. And so we believe that this mission is an achievable goal, and we're looking to do that. And in order to facilitate the goal, in 2012, we set up the OpenStack Foundation. which aims to protect, empower, and promote OpenStack software and the community around it. And we're drawing a line, an emphasis on community today, because everyone in this room has the ability to shape OpenStack and make it better. So our governance structure has a board of directors. You saw some of the sponsors, platinum and gold members on a few slides ago. We have 8 seats on the board for platinum members, 8 seats on the board for gold members, but we also have 8 seats on the board for individual directors, which means that if you join the OpenStack community, you can even participate on the OpenStack board if you can get enough votes. And that's very, very unusual for a software project. So the board of directors sets the strategic direction and manages how the funding of the foundation works. We have a separate technical committee, which is actually elected from the people who write the code, and they determine how to answer any of the difficult technical questions. But perhaps one of the most important committees is the user committee, which is able to present at the board or the technical committee or to the general community to ensure that everyone here in this room is able to be listened to and able to make changes to OpenStack to make it support whatever you want to do. So OpenStack works on a 6-month release cycle. At the start of every 6 months, we have a massive conference where we bring everyone in the world together who has something to do with OpenStack and plan the next release, what it's going to look like. Some of that conference is traditional conference, like here, where seeing people give presentations, interesting keynotes, and some workshops. But there's a whole second side to this conference, which is basically developers sitting in a room, gathered around a projector. And on that projector, they have this document called an Etherpad, which allows multiple people to edit that document. And what they're doing is they're arguing about features and how is this going to be implemented, how is it going to be designed. And you are actually able to participate in that sessions as a user of OpenStack. Once that discussion has happened, the Etherpad will then become a blueprint, which is a bit more solidified design, and someone will choose to code that up. So this process is the beginning of the open design process, and we get into the open development process. So in the open development process, every single patch to OpenStack, every single change to the code goes into a review system, which is publicly available. And that means that anyone here today can actually log into that code review system and give a vote of -1, this code is terrible. But of course, we'd prefer you to review the code seriously. And actually what tends to happen is every single line of code in OpenStack has been reviewed by at least 3 people, the original developer and 2 reviewers. Typically, we have 6 people look at every patch, sometimes up to 20. And then what happens is, if the humans have said it's okay, we send it to the machines, the continuous integration and testing system. And as Mark showed on his earlier slide, we're building an enormous number of clouds every day. For every code change, more or less, we build an entire cloud to make sure that change actually has the expected impact on the code base. And then if it passes this barrier, it can be part of the OpenStack release. And so what we have is people working together to collaboratively design features, even if they're competitors. Every line of code is reviewed by at least 2 people, and there's an extensive continuous integration and testing infrastructure. And that means the code is very, very high quality. Documentation, translation, and infrastructure also has the same collaborative nature. And anyone here is welcome to join in any of these activities. So in terms of customization, OpenStack, I mentioned before, is very pluggable, very flexible. It can communicate with your hardware, but the code itself is also very easy to modify if you've got a particular requirement. And so, for example, the dashboard is a web application that it's very easy if you want to add your own logo. That seems to be very popular. That's very easy to do. Or you want to add a new panel. That's easy to do. If you've done a PhD in compute scheduling and want to make a very complex scheduling algorithm, you can add that into the compute scheduler. It's just a single Python file. And similarly with the object storage middleware, there's lots of opportunities for modification there. Some people have even made a system where when you upload an image, it automatically generates a thumbnail. And so there is this website called devstack.org, and you can download DevStack. It's a single shell script that you can use to install OpenStack all in one system. Very, very straightforward. So have a play around with the code. It's also good to test out. But as you're doing this, one of the things you should be doing is interacting with the community. Thankfully, all of you are here today and able to see the fantastic event that the Japanese OpenStack Users Group has organized. But there are some other resources available for you. So we have a site called Ask OpenStack, where you can simply ask and answer questions, anything to do with OpenStack. We have a bunch of mailing lists, which have a lot of emails. So tip for you, if you're signing up to the mailing list, set up a filter in your email client so that you don't drown in the email. And if you prefer more interactive communication, we also have IRC channels with lots of people in our time zone online. Your local user group, the Japan OpenStack Users Group, meets up regularly, and they have their own mailing list in Japanese, very convenient. And if you are using OpenStack, you should participate in the OpenStack Users Survey. We take this very, very seriously. It enables you to make comments, even negative comments, about your experience with OpenStack, and tell us what we should change and what you're using, so we can give priorities to the developers. And one quick story, everyone in the OpenStack community is really, really friendly. So you should definitely consider asking a question to anyone, even if you may not have met them before. So one time I had someone ask me a question, a very complex networking question, and I didn't know the solution. But they also found this blog post, and I suggested that this person ask that blogger, the question. And it turns out that that blogger actually responded within about 2 hours and had solved their networking problem, even though they'd never met and they were in different countries. It was just really a great example of how everyone in our community is working together to make great software. And of course, if you're really interested in OpenStack, one of the best places you can further your knowledge is coming up May 12th to 16th in Atlanta in USA. We're going to have our next design summit. And so you can go there, you can do a workshop to do some training on OpenStack, you can listen to the keynotes to determine the strategy of how the community is going, you can also participate in case studies looking at how people are using OpenStack, or you can also join in the developer sessions and find out what features they're up to, and if you have a use case for those sessions, definitely our developers love hearing from users. And so as Mark said, all of the way software is being made today is changing, and we really think that everyone in this room has a vibrant place to play in our community, and we would welcome you to participate. So that's all the slides I had. I'm not sure how much time we've got, but hopefully any questions will be nice and easy for the translators. Thank you very much.
トム・フィファイルド様ありがとうございました。